Hello YouTube, this is Robert. I haven't made any videos in a while because partially I've been having so many quality issues in my opinion with my videos, in that I had a new camera and I'm not quite used to it yet. So the focus was really awkward in my last video at times because I didn't know really how to change the focus. Um, Also, just like the camera ship, my camera turning sideways and wobbling around so much when I was like trying to take video and ride it at the same time. I mean, it's just too difficult. In the future, I'm gonna have to figure out a better way to take camera shots, so it's not quite so bad. But in the meantime, this is winter, so it's really sort of odd making a video now. My steam bike's stored away for the winter. It doesn't like cold, water gets 32 degrees, it sort of freezes. That's a problem. But in the meantime, I've started working on something for the bike that will basically regulate the water flow so that it will only allow a certain amount of water to get to the boiler regardless of engine speed. Because once you start going faster, I start going more like 15 miles an hour or so, which is my top cruising speed I've achieved. You start basically pumping so much water that the boiler, if you close the bypass, couldn't handle it. And basically your steam temperature would drop, and the efficiency drops with temperature. With monotube boilers, the temperature is more important than how much, or your pressure, I should really say. Because the point is that you have a high temperature that's superheated. So the whole boiler is superheated. And if you pump too much water in, more water in than the boiler can keep up, then it causes your temperature to drop, which causes your efficiency to drop, which then means you use more steam because you're being less efficient, and it's a repeating cycle. And that's a self-fulfilling prophecy thing. And so basically, I've been recommended to do this for a while. I've just been sort of a little bit lazy about it. I've been busy with other things. A man by the name of Carl Peterson, who worked with Smith, he's published an article about building a something called a differential pressure control valve, or differential pressure bypass flow control. It's all a mouthful of words. And like I said, basically what this device does is control your water flow. Now, I actually have planned a sort of a sketch for this with my bike, and it's supposed to be scaled correctly. But nobody ever really built. There was only one example of that built, and there's hardly any sort of notes about how well it worked, and I was really unsure about how well it worked and if it was worth all my time to even build one. I've decided, since I've been a little bit bored this winter, I'm taking a winter session. In some spare time I have, there's a student machine shop, and I'm going to work on building this control valve. And so I'll tell you how it works. You have several parts. You have two pipe crosses, and you have a piece of 3/8 pipe, and then that's the body. And inside you have a 3/16 rod with a leather cup and some washers and a screw and a spring. And basically how it works is water comes in this side, this opening right here, and this is 1/8" pipe crosses. So this comes in one, and then it goes through to the other side, and there's a valve here. So there's your regulating valve right here, and it lets it flow over to this other chamber. So there's two chambers, and so once in the second chamber, it pushes back against the piston here. So it's pushing on this side, and then it's pushing back against it once the water comes to this side. And it just goes out one of these. I'm not going to have dual exhaust. I'm not going to be fancy like that. That's too much work. But basically the idea is when you start pumping too much water through here, so the valve flow, basically this valve starts restricting the flow, so there's more water coming in than can flow through this valve, you cause a pressure difference. So it's higher pressure here than here. So it pushes the piston this way, and as you can see, there's a taper right here, and this leads to a line that will go back to the water tank. And so as pressure increases on this side, the piston goes this way, and as a result, it opens the water to flow this way, essentially allowing the excess water to flow back to the tank once you get going faster. And so this not only does this actually even out the fluctuations, so it's better for the system in general because you have it's not pulsating quite as much, but also it's limiting your water flow. And so far what I've done is I've made the cylinder part, and as you can see I've actually threaded both ends. It's sort of hard to see. I suppose you can actually see through to the other side where there's more light. But yeah, so I've made the cylinder part. I've made the tapered pin part, as you can see here, and I have my little cup, my little leather cup, which basically at this point I've just soaked in water. I've been told I should soak it in oil, but I found such an easy time of making this that for now I'm just going to deal with this. And basically I soaked it in water and shoved it into the cylinder, and it made this, a piston-like shape. And so there's the taper, and this is like a 10-degree taper. I also have chosen out a spring, which is slightly smaller than the half-inch diameter of the cylinder. And I'm going to have to cut this down, obviously. I mean, this would be ridiculous, and plus I worry about it bending too much. But anyways, once I have this, I'm still waiting on the pipe crosses, so I still have to thread the pipe crosses so that I can put this 3/8 piece of pipe on an 1/8 inch pipe cross. So it's sort of backwards, but so once I have the pipe crosses and I thread those, then basically the thing will be complete. And basically what I'll do is once it's complete, then I'll test it. So in one of those spare plugs that I had, because you only need one outlet, I'm going to put a pressure gauge so I can tell what the outlet pressure is on the like the pressure of the water. And basically I'm going to test the flow rates at different pressures and different sort of flow rates, just opening the valve more or less, and see, because that's one thing the author of the article asked. That's what Carl Peterson asked, if somebody built this to test the flow rates. Just curious. Plus, then you sort of figure it out before you put it on the bike if it's really working. Because once I put it on the bike, it's going to be sort of hard to tell in that if it's like leaking, and it's just good to test it. So anyways, that's what I've been up to.